We are going to finish the 8B notes with the third part of the lectures on the notes here. We are going to be doing some distributing and foiling, just like we learned back in Unit 6, except with square roots and cube roots. And then we're finishing with rationalizing the denominator. But our first part here is we're just distributing the square root of 6 to each thing inside the parentheses here. So, what we have to look at, there's really an invisible 1 out here, so I multiply what's outside the square roots together. 1 times -5 is -5. The square root of 6 times the square root of 6 is the square root of 36. Now, this next one here is plus. The 1 times 7 is the 7. Then it's just the square root of 6 there. So really, we multiply what's under the square roots together and what's not under the square roots together. Now, from here, we can do a little simplifying. The square root of 36 is really 6, so -5 times 6. So that's -30 plus 7 square root 6. This next one, I'm going to distribute the cube root of a to each one of these. So now, since they're both cube roots here, and there's nothing outside the cube root, so really I'm just focusing on underneath the radicals here. So it's still the cube root. 2a times a squared is a cubed, plus cube root of a times a, that's going to be a cubed, and then I see 16, and I can see I can break that into 8 times 2. The reason why I'm doing that is I know I'm going to try to pull out a cube root, and I see 8 is in 16, so I'm just going to do that here. Now, let's simplify this a little. A cubed, cube root of a cubed, 3 divided by 3 is 1, so it's really a cube root of 2, plus the cube root of 8 is 2, the cube root of a cubed is a, then it's just plus 2 underneath there. So it's a cube root of 2 plus 2a cube root of 2. So these are identical like terms. Now, what we cannot forget is there's a 1 out front here. So this is really 3a cube root of 2. All right, the next one here, number 12 here. This is just good old foiling here. 4 root 3 times root 3. That's really 4, because there's nothing outside here. There's just a 1. 4 times 1 is 1. Square root of 3, square root of 3, that's the square root of 9. And as you get better with this, you're going to want to simplify that to a 3 instantly, but I'm going to overemphasize showing all my steps. Here I do this. 4 times -5 is -20. Square root of 3 times square root of y is the square root of 3y. Plus square root of y times the square root of 3. They're both under the square root, so just square root of 3y. And the last one is going to be -5 square root of y squared. So let's start simplifying here. Square root of 9 is equal to 3, so 4 times 3 is 12. -20 plus 1, remember there's a 1 there, so it's -19 square root of 3y. The square root of y squared is equal to y, so this is -5y. And so that would be my answer. So really, we're foiling it out, and we're doing a lot of stuff from the past. All right, this one. This is a very, very important one. If you notice, square root of 12, square root of 2, 5 squared 11, 5 squared 11, 1's plus, 1's minus. So really, this is difference of squares, isn't it? Except we're going backwards. We're foiling it out. So now, when we do this, this is special because the middle term goes away. The square root of 12 times the square root of 12 is just the square root of 144. And I know a lot of you want to write 12 down. Please do. So that's the first one. Then we distribute this. This is -5, the square root of 132, plus 5, the square root of 132. Then it's -25, the square root of 121. So now, let's simplify. The square root of 144 is just 12. Now remember, the middle term goes away. Minus 5 plus 5. These cancel. Now, the square root of 121 is 11, so I got to do 25 times 11, which is 275, so it's minus 275, which is equal to negative 263. And the last foiling one. Now, it doesn't look like foiling, but remember, this is squared, and when it has the plus sign in here, you just can't distribute 2. You got to write out another 6 plus the square root of 5, and now we got a foil. 6 times 6 is 36. 6 times 5 is plus 6 root 5, plus 6 root 5, plus the square root of 25. So we have 36 plus 12 root 5 plus 5. 41 plus 12 root 5. Okay. They'll take some practice on this, but these aren't too bad. The rationalizing the denominator, which is the last section of 8b. And I know 8b was a long one. So they call it rationalizing the denominator because you do not want square roots or cube roots on the bottom of a fraction. And it's a really nice trick that you will actually find useful in some interesting calculus questions, and sometimes in pre-calculus as well when you're trying to find limits. I know that's in the future, but I'm just going to be, again, right now we want to get rid of the square roots on the bottom of a fraction. So, I got to look at it. Since this is a square root of 5, what can I multiply to make this a perfect square? Well, this is a pretty simple one. All I do is multiply it by the square root of 5 and the square root of 5. When I multiply this out, I get the square root of 85 over the square root of 25. Square root of 25 is a perfect square, so it's just 85 over 5. Now, you must resist the temptation to reduce the 5 and the 85. This 5 is not under the square root. This is under the square root, so they're not the same. You cannot reduce them. Now, if they're both outside the square root or both inside the square root, yes, you can. We did that earlier when we were doing our division. But if one's in, one's not in, you cannot reduce. So again, this next one here, I'm looking at the square root of 3. Well, if I multiply the top and bottom by the square root of 3, I'm going to end up with 21, the square root of 6, over 2 times, now square root of 3 times square root of 3 is the square root of 9. Now I'm just going to simplify this. Square root of 9 is really 3, isn't it? Now, we can do this. We look at 21 and 3. They are both outside the square root, and 21 divided by 3 is 7. So I'm really reducing top and bottom by 3. So this is really equal to 7 root 6 over 2. All right, now this is going to be a difficult one. This is the cube root. So now these, we're always looking for the perfect squares, but now we're looking for a perfect cube. So if I have 3 in x, 3 times 3 times 3 is 27. X times x times x is x cubed. 27x cubed is a perfect cube, so I could do the cube root of that. But 3 times what is 27? Well, that's 9. So I'm going to do the cube root of 9x squared. 3 times 9 is 27. X times x squared is x cubed. Now remember, I always have to do top and bottom by the same thing. So after multiplying out the top, I'm going to have the cube root. Okay, so 2 times 9 is 18. And then if I put it in alphabetical order, it's x squared y. All over, now when I multiply this out, this is really the cube root of 27x cubed. They're both perfect cubes. Cube root of 27 is 3. 3 divided by 3 is 3x. And so now again, no cube roots or square roots on the bottom of the fraction. So this is the answer for this. And I didn't box that one up either. All right, this last 2 questions. This is where I'm going to need to remember what I did right here when I foiled this out. The middle term went away, so if you notice, no square roots anymore. So it's just applying the difference of squares again. So now if I have 4 minus the square root of 5, I want to multiply, and they call it the conjugate. Since this is minus, I'm going to multiply top and bottom by 4 plus the square root of 5. 4 plus the square root of 5. If this is minus, this is going to be plus. And the next question that starts off plus, and I'm going to do the minus one. So now, I got to multiply it out. Now again, you're going to notice the pattern after doing this a couple times, so you're not going to do it all, but I'm going to again show you the steps. 4 times 4 is 16, and 4 times root 5, there, one's in the square root, one's not, so it's just 16 plus square root of 5. When I multiply this out, 4 times 4 is 16, then I have plus 4 root 5, then I have minus 4 root 5, then minus the square root of 25. 4 root 5 minus root 5 cancels. 16 minus, well, the square root of 25 is 5. So the bottom is 11. So the answer is 16 plus 4 root 5 all over 11. Again, no square root in the bottom. And our last question of this section, since this is plus, I'm really going to multiply by 3 minus, not plus, I just said opposite. 3 minus the square root of x over the 3 minus the square root of x. Now this is a little harder, because the top I really got to FOIL it out, don't I? Turns out the top is actually going to be harder than the bottom. 5 times 3 is 15, minus 5 root x, and then I'm going to do the inside, minus 3 root x, and then minus root x squared. So now I can combine some like terms, can't I? The middle terms go away here. So 15 minus 5 minus 6 is minus 8 root x. And so then, I did make a sign error here, didn't I? Negative square root x times negative, that should have been a positive, shouldn't it? Plus x. So that's my numerator. My denominator. 3 times 3 is 9. And then I get minus 3 root x plus 3 root x minus the square root of x squared. Negative 3x plus 3x goes away. This is really 9 minus the square root of x squared is x. So my bottom is 9 minus x. Now, we must be very careful again. This goes back to mistakes we made in Unit 7. Can I reduce these two x's out here? And the answer is no, no, no. It's tempting, but I cannot factor an x out of all 3 terms on the top, nor can I factor an x out of both terms on the bottom. This is the answer. I cannot go any further. Alrighty, so that ends 8B, sorry. 8B is a tough one. I expect lots of questions on it, but hopefully this will help you out when you're getting through the homework.